Welcome to this electric field example. So when you're beginning to learn about electric fields, you are going to be running into some problems where you're going to have to calculate what the electric field might be at a particular point. Now, electric fields may be different at different points because of the fact that if you do have charges and they are settled around, and now we're going to assume that they're static charges, so they're not moving, then any point that you choose is obviously going to be different in terms of the distance between the charges and the point that you're interested in. So technically, when you're calculating the electric field, really it's an electric field at a point, unless your teachers ask you to calculate it at several points. Now, in this example, I want to be able to capture that particular calculation and give you a step-by-step process of how to think about this process in terms of finding out what the electric field might be at a particular point due to several charges. So not just one or two. Notice I have 4 charges in here. They're kind of scattered around the grid, and we're going to be finding out what the electric field is. Now, my assumption will be that you are familiar at least with the electric field in terms of the equation, how it kind of comes about. Okay, if you haven't seen that, I'll put up a link up above there. I did a video on that if you're going to be interested. Here, I don't talk about that. I just basically do the full out calculations and give you a step-by-step process on how to find the electric field. So as you can see here, we have 4 charges. So we have 1, we have 2, we have 3, and we have 4 charges right there. Now, we're going to make some assumptions in here in terms of their calculations. We're going to assume that the x and y coordinates, so this is a 2-dimensional kind of coordinate system, is in centimeters. All right, so we're going to assume that all of these values are in centimeters. So for example, when you're talking about charge number 1, you can see here, so it's at -2, and this will be it looks like it's 3 right there. Charge number 2, for instance, is going to be a 3 and 2 right here. And those values are in centimeters. Okay, so we'll try to find out what the rest of those values will be. So what our goal will be at first is to find the electric field at the point 0, 0. So basically at the origin. It does not have to be the origin. And I was contemplating, should I put it somewhere else? Technically, it doesn't matter, because the step-by-step process will show you exactly what you should do. So let's begin. So the first thing that I will do whenever I'm trying to solve for the electric field at a particular point, I'm going to try to go back and I'm going to try to collect all of the information that I have in here. So number 1, so this is step number 1, collect all the charges that you have, so that you know which ones you're going to have and how many. So collect all the static charges that you have. Now in our case, so they're already listed, so we have Q1 all the way down to Q4. All right. Now for all of these charges, so step number 2, once you have those, find out what the distance is from a charge to the point of interest. Okay, so we want to know what the distance now will be. So that's step number 2. So distance, and I'm going to label the distances. So D1, this is going to be from charge number 1 to the origin, D2, D3, and then D4. Now, technically, you can call it certainly R, which is going to be the distance. So from almost like a radius from the point of origin, wherever you're interested in finding the vector field, okay, in this case, the electric field, to whatever point of the charge that you have. You can use R, and that's mainly because of the actual equation that you use, right, for the electric field. So I'm just going to call them distances. It doesn't really matter. So since we have all of the static charges, they're already listed, so I'm not going to relist them here for us. But I do want to be able to find all of these distances, right, that I have in here. So if I go back, so first I want to be able to find what this distance will be. So distance number 1. Now I'm going to actually kind of go back in here because I have it prepared in decimals. So this is the entire thing. So I've kind of labeled this out in decimals. So really what I'm trying to do, okay, in here is I'm trying to find what the distance is. This is from your first charge. So really, this is what I'm trying to do. So D number 1 is equal to, okay, from the charge to the origin. So that's going to be, now in decimals, in the kind of geometric kind of decimals that I have, I can label an actual segment. So O is just the origin. I've labeled that in, okay, before starting this video. And then, you know, Q1 is the actual distance that I have. So that Q1 is the point where my charge will be. So I'm trying to find out what this actual distance will be. And I'm going to do that for all of the distances, right? So within here. Now, if I go back, because, you know, you may not be using decimals, okay? So if it's quizzes or tests or something or assignments, you might actually have to calculate this. So you have to kind of go back and think, all right, so what and how do I find this thing out? So I'm going from this point to the origin. This is where you're going to have to be using your Pythagorean theorem, right? So whatever this distance might be, okay, now this, it turns out that this point is at -2 and this is at 3. Notice 2 is over here, okay, and I'm just counting here the grid. So this is 1, this is going to be 3 right there. So that is my distance. So what that is telling me, I can now create a triangle. Now, it doesn't matter how you create your triangle. So this is going to be your Pythagorean theorem in here. And I'm going to know that this height is 3 and this height is 2, at least in magnitude that I have. So I can find out what this distance, so D1, is by simply the Pythagorean theorem. So by the Pythagorean theorem, I know that this is going to be, you know, the square root right there of, this is going to be 2 squared plus 3 squared. And I have my actual distance. So notice it's going to be the square root of 4 plus 9, or simply the square root of 13. I'm going to just leave it, okay, like that. Okay, you can certainly change it to decimal if you want. No need for it. This is actually an irrational number. So you're going to repeat this process. And I'm not going to show you that. Okay, I'm going to speed up the video for you. But now I'm going to do the exact same thing for D2, for D3, and D4. So I need those distances for all of the charges that I have. So if I go back in here, so my second one that I will do is, you know, let's say if this is Q number 2, so there you go. And you're going to always do that. Even if it wasn't at the origin, you can always draw the line, okay? And then you can find out and create a right angle triangle so that you can use the actual Pythagorean theorem for this. So once again, you know, I can go back in here, I can create a triangle right there. So this particular Q2, it looks like it's located at now at 3, 2 right there. So this is going to be 2, this is going to be 3. So this is my distance D2. Now notice, okay, so because of the 2 and the 3, the answer is actually going to be the same, right? So in this particular for this particular example, okay, so what I have, so 3 across and then 2 upwards. In the other one, you know, it was 3, okay, and then it went 2 and 3. So these distances will be the same. Now, I haven't scaled this, you know, in the same way, so the triangles look a little bit different, but that's what they will be. So now I'm going to do that also for Q3, and I'm going to do that for Q4, and I'll be right back. All right, so that's that step. All right, so welcome back. So there you go. So I have now all of my distances, right? So that was the step that I wanted to do. So now what's next? Well, once you have the distances and you know what the charges are, this actually isn't very difficult, right, anymore. So now our next step, so this is kind of step number 3 that you would have. So step 1, you collect all your static charges. Step number 2, you calculate the distance to the point where you want the electric field. And now step number 3, now you do actually calculate. So you're going to calculate the electric fields. Okay, so this is going to be E1, electric field E2. Okay, this is going to be E3, and this is going to be E4, meaning you're going to calculate what the electric field is with respect to each charge individually, right? So we want to be able to find out what the electric field is for the first charge. So this now goes back and you have to kind of recall, all right, so what is the formula in here? So this was, okay, so K multiplied by whatever charge it was. So if you use small q, big Q, does not really matter. And then it is divided by whatever the distance was. So now, you know, typically you might draw out r squared in here, but, you know, we have used d, okay, so distances to the actual amount. So that's not very hard, right? So K is just 8.99 times 10 to the 9. So that is the constant that we have. And then it's going to get multiplied by whatever charge that you have in here. Now I'm going to be finding just the magnitude at the moment. This is a vector, right? But I'm going to be finding out what the magnitude here is. So I'm going to go back. Okay, so that was 1.5 times 10 to the negative 10. And so 1.5 times 10 to the negative 10, and then divided by whatever the distance was. Hence, this is why we needed the distances. So this is going to be 13. Notice, because you kept the square root, so now that you square it, it's going to be just 13. So again, this isn't very difficult, right? I can pop out the calculator in here, and I can substitute everything in. So 8.99 multiplied by 10. This is to the 9, and then it's going to get multiplied by, so next, so this is 1.5, that's the charge itself, times 10 to the exponent of negative 11. Whoops, that's not what we wanted. So negative 10, and then divided by, and this is going to be, well, this one's easy because it's squared of square root, so this is just divided by 13. Okay, now we have to be careful in here. So please recall, okay, so this, you know, you are going to have to, so this negative 13, you're going to have to divide by 100 because it's in centimeters, right? Now, if it was already in meters, then you would leave it the way that it is, but this is in centimeters. So I am going to, you know, take this, okay, entire thing, I'm going to actually re-input this whole thing in here. So this is going to be square root of 13. Okay, then divided by 100, and I'm going to actually square it. Okay, so in here. So it's going to be 13 divided by, I guess, 10,000. Okay, so in this case, now I'm going to hit equals. And now I have what the force is. So the force is 1037.30, you know, 7692, etc. And this is newtons per coulomb. Now, that's the magnitude that I would have in here for my result, right? So this is what the magnitude would be. Now, if I go back in here, so I'm going to delete all of these things because I don't really need them anymore. Okay, so per se, so I'm going to delete all of that. Okay, so let me clean this up, okay, a little bit for us. Okay, the bottom I'll leave for the moment. Now, what do I know? Well, in which direction is this? Okay, so because the charge was positive, then you know that, okay, right here, it's going to be pointing this away because we always assume that this is a positive test charge, right, when we're calculating the electric field. So we know it's going to be pointing in this way. Now, in what, you know, what is that angle or what is the direction? Well, this you actually know as well. So you are going to be able to find out what that angle is. Now, you know, I'm going to just sketch it, okay, for the moment. So it's going to be pointing out in this direction. We know its magnitude. If you want to know what this angle is, so for example, what this angle might be, okay, or you want to find out what this angle will be, you certainly can do that. But what you also know what the ratios are in here, because those ratios are going to be the same ratios that you utilized, okay, from the viewpoint of having, okay, finding out your distance, right, that you have. So it's going to be 2 and it's going to be 3 upwards, okay, so we can find out what that angle will be. All right, so what I'm going to do now is that I know what this electric field is. So this is E1. I know its magnitude, and now I can find out, I'm going to, you know, find out here what this particular angle, okay, will be. So now, how do I find that angle? You have to kind of go back to trigonometry, or you can just use what the actual ratios will be, right? Because ultimately, at the end, we're going to have to take this vector and break it down into its components, into its x component and into its y component. All right, but I'll do that in another step. So first off, how do I find this angle if you really wanted to? Well, that particular angle, so as you're going through, okay, so within here, this angle is going to match, okay, so as it goes right this way, so this angle is exactly the same as this angle right there, right? And that angle is coming back from, okay, so this particular triangle again. So if I want to know that angle, so let's say this is my opposite, this is my adjacent, right? So you can take in and say, okay, tan inverse of, and then opposite of adjacent, so right here, so that's going to be that ratio. Now opposite is 3, adjacent is 2, and then you have your angle, right? So if you go back in here into your calculator, you can certainly do that. So 10, it's going to be 3 over 2, which is just 1.5, and you have your angle, so 56, 0.3, etc. Okay, so that's your angle in degrees. But don't forget about this particular ratio, because that's really the ratio that we'll need. So I'm going to, leave that in here. So I'm going to write this out. So this is now at an angle of 56.3099. I'm going to keep a couple of decimal places in here for the future for this. So there you have it. That's my electric field from the first charge. Now, it seems like a lot of work. Yes, it is, because of the fact that you have to calculate the actual formula itself and you have to find what the angle is. Sometimes, the angles are very easy if they're especially unidirectional. In this case, it's not. So now what we have to do is we have to do this same process for all of these. So we've just calculated this one. Now I have to move over and I have to calculate this one. So once again, it's going to be this. Now in our case, so now I'm going to start putting these in here. So it's Q2 divided by the distance 2, okay, and squared. And again, don't forget, to keep this in meters, right? So just so that you have metric standard units. Now I'm going to do all of these calculations for all of the vectors, right? And then I'll come back, okay? And then I'm going to find out what all of the angles are, okay? If they're needed. All right, I'll be right back. All right, so welcome back. So here they are, okay? So here's the set, okay? So here are all the magnitudes that I have calculated right there of all of the individual ones. So now the next step is, I do need to know what all of these angles are, or at least the ratios in between there. So, how you can set that up. Okay, so now I found the first one, which is about 56 degrees. Okay, now for the second one, okay, I just want to be able to go back in here, because I also have to think about, okay, the fact that the charges might be positive or negative. So please don't forget. So for example, the first charge that we had was a positive charge. So as I mentioned, so this was going to be pointing in this direction. But the second charge is negative. So that means this is actually going to be pointing in this direction, right? Right there. So my second one that I would have in here, I'm going to try to remove all of this stuff in here, so to kind of clean this up. All right, so now what I have is this one is going to be in this direction. Now the magnitudes, I'm not scaling these properly at the moment, but I want to be able to do that. And now this angle, which is angle number 2, of course is going to be, so now opposite. So again, so opposite is this way, adjacent is this way. So the opposite now is 2. And then the adjacent is 3. So you're going to go back in here, and this is going to be 10, okay, inverse of 2 over 3, okay? So this is the angle that I have in here. And then I can find out exactly, what that angle will be, okay? So equals. Now I do want to go back, okay, to the first one in here. So now notice this angle of 56.3, that was this angle, right? So this is at this particular angle. If you wanted it with respect to this angle, right, so as you're going all the way around, okay, you can always take 360 degrees minus this one. So you're gonna have to be careful, right, how you label these things, okay? You either label it on your schematic, right, so as you're showing your answers so that your teacher can see how you're setting this thing up. All right, so now that is my second one. So within this one, so I'll calculate that, okay, and then I'll do the same thing of trying to find all of the angles for the third electric field and then the fourth one, okay, for these. And again, so now, okay, with respect to the third one, so this one is positive, so this is indeed going to be in this direction, so it's going to be pushing it away, right? So with respect to that, so it's going to push it in that direction. And then this one is negative, so it's going to be pushing it, okay, in this direction, or at least pulling it in this direction. And I'm going to try to label all of the angles. So when I come back, I'll draw kind of a separate, okay, diagram with the vectors shown so that we can see exactly what is happening. All right, so after a little bit of calculations, but I also wanted to be able to draw it out so that everyone can see it, okay, as you're watching this through. So there you have it, okay? So here are all of the individual ones. So E1, you know, E2, okay, yes, E1, okay, this is E2, this one is E3, okay, right there. And then we have E4, all right? So those are the vectors, and kind of I put up the magnitudes and then the angles that they create, right? So individually. So as you're going through. So now I have calculated all of these by using the formula and then using trigonometry to find the angles, okay, if they're necessarily needed for us. So once you have that, now notice that this was, you know, our next step. From here, what you have to do is now, so this is the next step, is you have to find the overall electric field, which is going to be the sum. So this is the superposition of all of these individual ones. Now, of course, they are vectors. So this is going to be annoying. Now, I didn't say that this is going to be easy in terms of, now, it's not hard, but it's just laborious, right? Where you have to do quite a lot of quite a lot of calculations through. So what you should do in order to do this, now if you go back to trigonometry and you're talking about adding up vectors, right? Because this really is the addition of 4 vectors now. You have the magnitude, you have all of the angles, okay? Now you just basically break them down. So you're going to be breaking down this into its x component and into its y component. So meaning the vector you're going to break down. So I'm going to show you how to do one of them. And then, of course, I'll do the same thing for all of the other ones. So what I'm referring to now here is, for instance, if I take this vector, so E1 right here, I know what the angle here is. I can break it down into its x component and into its y component. Now, why am I doing that? Because of the fact that I will do that for all of them. So that means for E2, I'm going to break it down into its x component, into its y component. Okay, and then here, you know, y component, x component, etc. And then once you have all the x components and all the y components, then you can just add them up. You can just literally, okay, do your additions and subtractions. You're going to get an x component and a y component, and that is your result. Now, from there, once you have your x and your y, you can go back and create the overall magnitude and also the direction, all right? So here, let's do the first one. So I'm going to break this thing down. Okay, so here it is. You know, so I'm going to do it with respect to kind of, okay, the way that it looks like. So this is what we have. We know what the angle is. What I'm doing is I am taking this right here. All right, so let me steal it away. Now I can go back in here because I had all the calculations. So I'm going to steal all of this away in here so that I have this. So I'm just going to duplicate it, bring it down for us. So that's going to be for one of them. There it is. Okay, so that is the size. Okay, and now I'm going to break this down. So here's going to be the X component. Okay, and then I'm going to have the Y component. Now notice Y is going to be negative in here because of the fact that it's pointing downwards. So now, so this is for the first one, and this is with respect to the X component, it is equal to. So now, what is that equal to? It is equal to the magnitude, 1037.3076, etc., multiplied by, now I need this angle, right, which I do have, so right there, and that is going to be the cos, right, because it is, okay, cos meaning the X component that I have. So it's going to be multiplied by cos of 56.30993. Now, if you remember, so this is, cos of 56.30993, so that just goes back, okay? You've calculated actually the distance, so you calculated the hypotenuse, so you may remember, right, that you actually have all of these ratios in here, okay? So you can calculate that quickly. So I'm going to put this back in here, so it's 1037.3076. How many decimal places you want to keep here is up to you. You can keep 3 or 4, okay, if you're a student, but you can ask your teachers as well. And then this is now multiplied by cos of the angle, so 56.3093. Okay, so this is going to give us what the answer is. So that's 575.39. I'm going to, keep an extra kind of decimal places in here. So that is, again, newtons per coulomb in the X direction. So that's the positive value. If you want to break down the Y component, so this is going to be the Y component of our value, the same exact thing. So you're going to be multiplying this through, but now you're multiplying it instead of cos, you're going to have to multiply by sine, okay, of the angle. So 56.30993. So if I go back in here, okay, so let me delete this. It's going to be times sine and 56.30993 equals, and you have 863.009. Again, I'll keep up to 3 decimal places, but this is negative, right? So please remember that because it's downwards. So now you've broken it down into its 2 components there. So once you have this, as you can see, it's laborious, but it's not that hard, right? Because you have to now do the same thing for this, and for this, right? So you're going to have all of the components. So now we've just done this one. Okay, now I have to do this one, and I'm going to have to do this one, and I'm going to have to do this one. So let me do that calculation. Okay, and I'll do it in fast forward fashion so that you can see what the answers will be. And then, okay, we can then collect all the X components and all the Y components and be pretty much, okay, done finally. All right. All right, so that was a little bit torturous. Okay, so here it is. So here are all of the components. I put the X components on the left and then the Y components on the right. You notice some of them are positive, some of them are negative. So it just depends on the actual vector itself. So now once we have this, okay, so the kind of last step here would be that we have to now capture. So all of these. So notice we have to take all of the X components, we have to add them up, and then we have to take all of the Y components and we're going to have to add them up, and then we're going to get a result, right? So that result is going to be the overall, okay, electric kind of field at that particular point. So, you know, let me add these up. So I'm going to add those up on the left and then add them up on the right, and then I'll be... All right, so I've added them up, okay? So this is what it gives us. So it's not super, hard now that you hopefully can see what that process will be. And this is, of course, the vector on its own. So it would be pointing to the right and downward, right? So this is how it would look like overall in terms of the overall vector that would have been gathered there. Now, if you want to find the overall magnitude and then the actual angle itself, then of course you're kind of are back to, so you have to take now 705 squared plus, okay, so this is rounded, so it's going to be a little bit off, but that's fine. I hope that you can see, okay, what I'm doing. So this is going to be the magnitude because we want to know the hypotenuse. And then for the angle, so you're going to have to take 10 inverse. Now notice 705, so it's going to be in this direction, okay, and then 814, so it's going to be downwards, so it's in this direction. So when you're finding your angle, so this is what we are finding, that's the resultant right there, and then, your angle would be this angle that you find, right? So this would have been your opposite, this would have been your adjacent, so your opposite is down, which is 814, your adjacent is 705. There's going to be 10 inverse, okay, of opposite over adjacent, 814 over 705, and that gives you what the angle will be, right? So that is a really neat, okay, kind of way and a full out, long kind of step-by-step that you can see on a very hard example. I doubt your teachers are going to give you 4. I mean, unless it's an assignment or a project, but on a test, they shouldn't be giving you 4 charges, maybe 2, maybe 3, but even 3 might be stretching it because of the fact that it would be, I mean, unless there's some symmetry that you can find out what the answer is in terms of cancellations. But 4, once you see this and you understand this example, then this makes so much more sense. Let me just compute these final thing so that you have the overall electric field, all right, for this example. All right, so there you have it. Okay, so that's the final answer here. And I put the 49, I've just labeled it in case, I encourage you to do that, so your teachers know which angle you're referring to. If they want it with respect to the X original, so you can of course take this, okay, and, it's going to be 360 minus. So really, if you wanted to know what this angle all the way around here is, that's, I guess, 311 rounded, okay, so if they wanted that angle. So that is it, okay, so torturous example, but if you understood this example and you walked yourself through it, I hope that now you appreciate, the power of vectors, power of trigonometry, understanding that Pythagorean theorem is actually kind of useful when you are talking about vectors. Now, the crazy part is that this entire calculation was only computed for, okay, this particular point. Now, if you wanted to have it at this point, or at this point, or at this point, you would have to do this calculation all over again with respect to every single point, because the electric field will point differently at different points because it's a different distance to all of the charges. Okay, so now they will not do that for you unless you start utilizing some major software, but not if you're foundationally learning about this. Now, in this example, it also asked us, case in part B, okay, so within here, what if you place the charge in here, okay, at this point, now that you know the electric field, right? Like, what would be the force on that charge? Well, now, once you know what the charge is, then it's very easy, right? Because, once you know what the charge that you're placing and you know the electric field, you just multiply the two, right? So you can take this and you can multiply it by the electric field at that point. That's the beauty once you know the electric field. Okay, so you're going to just multiply the two magnitudes together. The angle will not change. So this is a rather simple problem because of the fact that, recall that your overall, so the force, so the electric force on any charge is just equal to the charge times the electric field at that point. But we've just found this and you've been given this. So you can just multiply the two. The angle does not change. All right, so you just multiply the magnitudes. All right, that's going to be it, okay, for this example. Thanks for watching. Hit a thumbs up if you found that this was useful. Happy studying.